Alright, hello and welcome back. We're going to be looking at a lesson here that I honestly don't always do this early in the year, but I'm going to try it right here because it's also an excellent review for like arithmetic with signed numbers, and I'm even going to throw in fractions a little bit. And if we have a lot of trouble with excuse me, if we have a lot of trouble with the signed numbers and the fractions part, we'll go back and work on that if we have to. But if we don't have to work on that, and this works as the review, it'll save us a lot of time. And so this is an introduction to matrices, which you might not know anything about yet. Alright, and so really there's only a couple basic goals here. We want to understand what a matrix is, and the plural matrix is matrices. And we want to be able to add, subtract, and multiply with them. We're going to basically do arithmetic here. And so it's not the movie, which is getting older now, so that might not even be the first thought that some of you think of when you hear matrix. But a few years back, when you first heard matrix, that was what sort of the average person thought of, was this movie. It came out in the late 90s or early 2000s. A matrix in mathematics is a rectangular array or arrangement of numbers into rows and columns. And so this isn't a matrix, but this is. You're usually going to see a matrix named with a capital letter. It's going to be enclosed in brackets, and then there's going to be numbers within the matrix, and they're arranged into nice, neat rows and columns. And in case you've forgotten, rows would run left to right. They're horizontal. Columns are up and down. They're vertical. So this particular matrix has 2 rows and 1, 2, 3 columns. In case you have trouble remembering that, think about when you go to the theater to watch the matrix, you would sit in rows. If you went to a really nice theater, they probably wouldn't be showing the matrix, and there'd be columns in front of it. Nice marble columns, because it's a fancy place. And that's not a great mnemonic, that's not a great way to remember it, but it's the best that I got. And the point of matrices that I'm hoping to get across in this lesson is that they're not exactly the same as numbers, but they have a structure very similar to numbers. And so that idea of talking about rows and columns, that gets us into the dimensions of the matrix. So this is a 2 by 3 matrix because it has 2 rows, 3 columns. The individual numbers within the matrix are called elements, and it's not uncommon to identify them using this double subscript notation, where this is the row number, and then the second part of the subscript is a column number. So this is first row, first column, which happens to be a 2. First row, second column, happens to be -5. And then one last example of how to use this. Second row, third column, happens to be 1. We're going to agree that when you read off a matrix, you start in the upper left-hand quarter, you read all the way across that row, and then you skip down to the next row and go ahead and read that row. That's how we're going to read them. Well, what would it mean for 2 matrices to be equal? Well, first off, their size would have to be the same. The dimensions are going to have to be equal. And then once the size is the same, the corresponding elements, you have to match them up and make sure they're equal. And then another sort of phrase worth hearing about is what would it mean to have a 0 matrix? It's probably not going to shock you terribly that it's a really boring matrix where every element is 0. The part here to be aware of is that any size matrix, no matter what the dimensions are, basically, you can have a 0 matrix. So it would just be every element's 0 no matter what the size. Alright, and so we're going to add matrices. So here's how you find the sum of 2 matrices. First, you can only find the sum. You can only actually do the addition if the dimensions are equal. And so here's an example of 2 pretty simple matrices. This is a 1 by 2 matrix. This is a 1 by 2 matrix. It's probably not going to shock you that your answer is a 1 by 2 matrix. And then to find these new elements, where does the 3 and the 4 come from? Well, all you have to do is take the corresponding elements and add them together. And of course, corresponding here means like same position as the other matrix. So like first element here, first element here. Well, 3 and 0 is still 3. Negative 1 and 5, when you add them together, would be 4. And so sort of the point of matrices is, okay, they look a little different, but I bet if I just put this problem in front of you the way it is, this is probably the answer you would come up with if you tried it. What's the other thing we're going to do with matrices? We're going to do what's called a scalar multiplication. A scalar is any, in matrix talk, is any real number, and usually you restrict it to not being 0. Constant starts with C or K. Real numbers are constants. They don't change their value. And so sometimes when you're just talking non-specifically, you'll see C or K used for constant. And the idea of a scalar is that it changes scale. And that's the idea of multiplication, is to change scale. And so again, if I just put this problem in front of you and didn't tell you anything about it, if you actually tried it, I bet a lot of you would come up with this as the answer, because you would look at this and say, okay, I've got whatever this is, and it looks like I'm trying to multiply it by 2. And so maybe I should just multiply each number by 2. So negative 3 times 2 is negative 6. 0 times 2 is still 0. 1 times 2 is 2. And 1/2 times 2 is 1. And that's it. It just works the way you think it should. The reason why it works the way you think it should is that even though matrices first appeared in Asia a long time ago, sort of the modern version that looks like what we're going to work with was basically designed by mathematicians in the late 1600s, 1700s, early 1800s to work this way. They wanted it to work like normal numbers, but it actually be sort of, that idea of it's a collection of numbers sort of all at the same time. And the point of matrices was to help them solve other problems, which we might be able to get into a little bit later in the year. But for right now, just accept that they're useful. They're used in a lot of different ways in math and science. The way that I could tell you that they're used in, that I could actually kind of show you a little bit about, just so that it does make sense, is that computers don't get sort of this idea necessarily of take this image on the screen and slide it over this way that far. They're moving something around on the screen, but they can work with matrices really easily. And so it turns out one of the easiest to understand applications of matrices is actually basic computer animation. Taking a shape on a screen, describe it using a matrix, apply this other matrix, and the computer sort of knows to move the shape this way. And again, if we have a little time later in the year, we'll work with that. The word matrix, since that's not a word that you necessarily hear a lot in English, and anytime I have a math word that I put out there for you all that you don't necessarily encounter a lot outside of math, you might have noticed that I try to give you an idea of where that word comes from or what it means. So the word in English that matrix is probably is sort of the most related to is actually mother, because they both are coming out of the Latin word. Again, I don't speak Latin, so I could be completely messing this up. Mater. And so that's actually it already in terms of the vocabulary. The rest of this lesson, which we'll just see how long it takes to work, is actually working a few examples here. And so we've got these 4 arithmetic problems that we're going to work using these 3 matrices. And these matrices all happen to be 2 by 3 matrices, 2 rows, 1, 2, 3 columns. And hopefully I don't want you to think that every matrix has to be 2 by 3 just because the examples we're using on this sheet are. But I thought it would work well to just go ahead and make every matrix on here the same size so that we could kind of combine them however we like. By the way, if anybody's noticed that we've talked about, add, subtract, multiply a little bit, we intentionally kind of left divide out. And that's for a reason that we probably would not be able to get into in this class. It's also something that you might not even get into in Algebra 2. It's a pretty complicated concept. And so if you're watching this in Algebra 1.5, we definitely won't really get into the idea of division. We might in Algebra 2. We'll just have to see. And so here we go. We're going to find a plus b. So here's a, here's b. Our answer is going to have the same sort of structure. It's going to be a 3 by 2 matrix. And I basically just need to fill these numbers in. I'm going to fill them in just purple here. Alright, so what is 1? And we're adding. So what is 1 plus 3? Well, it's 4. Okay, and then back to a. Negative 5 plus 7 would be 2. 4 plus negative 1 would be 3. 0 plus negative 2 would be negative 2. Negative a little stronger there. There we go. 3 plus 8 is 11. 2 plus 1 is 3. And we're done. That's the resulting matrix when you add matrix A and matrix B. So what about 4C? Well, again, it's going to have the same structure. It's kind of a stray mark. Let's get rid of that. It's going to be 1, 2, 3, 1, 2, 3. It's going to have the same structure as C, but we're going to find a new matrix by changing the scale by 4. So we're going to scalar multiply by 4. Well, 4 times a half is 2. 4 times 7. 7 doubled is 14. Double again is 28. So 28. 4 times negative 1 is negative 4. 4 times 0 is 0. 4 times 4 is 16. 4 times 3 is 12. And so all we had to do to find our new matrix is find what happens when you take these elements in C and multiply each of them by 4. So again, it's kind of common sense. This one's a little tougher than the rest, or at least than these other two. So 3b minus 2a. So now we kind of have to combine both ideas here. We're going to take b, multiply it by 3, take a and multiply it by 2 and then subtract, or we could go ahead and multiply by negative 2 and add. Either way, you should get the same answer as long as you're careful. So we'll start by finding 3b. So we're going to take b and we're going to fill out the problem with our new numbers. And these are both going to be 3 by 2s. Or excuse me, 2 by 3s. So we're going to have to fill all these blanks in. Well, 3 times 3 is 9. 3 times 7 is 21. 3 times negative 1 is negative 3. 3 times negative 2 is negative 6. 3 times 8 is 24. 3 times 1 is 3. Again, when you're doing all these problems, you have to be a little careful with signs, because if you get one sign wrong, you're going to be off a little bit. Alright, I've put the subtraction here, so all we're going to do is take a and multiply it by 2. So 2 times 1 is 2. 2 times negative 5 is negative 10. 2 times 4 is 8. 2 times 0 is 0. 2 times 3 is 6. 2 times 2 is 4. Now to get a final answer, we just need to subtract. Nine minus 2 is 7. 21 minus a negative 10, well, that becomes 21 plus 10. So that's 31. Negative 3 minus 8 is negative 11. Negative 6 minus 0 would still be negative 6. 24 minus 6 would be 18. And 3 minus 4 would make negative 1. And that would be our final answer. That's what we get when we multiply b by 3, a by 2, and then subtract as indicated here. Let's do kind of a similar deal with 1/4 of a plus c. So this is going to be the 1/4 a. Alright, so 1/4 of a. And this is kind of the vicious one because 1/4 is not going to go into most of these numbers very nicely. In fact, I might need to give myself a little more space. Give myself a little more space. And, oops. Myself a little more space here, sorry. Because they're going to be fractions. Alright, and the work deleted is a little distracting. So there we go. That's gone. Alright, sorry about that. Alright, so 1/4 of 4 would still be 1/4. 1/4. 1/4 of negative 5 would be negative 5/4. 1/4 of 4 is just 1. 1/4 of 0 is still 0. 1/4 of 3 would be 3/4. And 1/4 of 2 would be 2/4, but that would reduce to 1/2. Okay, so now what I'm going to do is write down C here, but I'm going to make a least common denominator in the process. So I'm going to take C and I'm going to change the way it looks, but it'll still be equal because the corresponding elements are going to be equal. But I'm going to change it so that I have all the common denominators I need. Well, right now it would be a half. I need fourths. So we need to change the 1/2 to 2/4. 7 in fourths, well, would be 28/4. Negative 1 can just be negative 1 because that piece was actually not a fraction. The 0 right here can still be just 0 because that wasn't a fraction. 4 in fourths would be 16/4. 3 in fourths, excuse me, 3 in halves, would be 6/2. And then now I'm going to add them together and make sure that nothing simplifies. So 1/4 and 2/4, excuse me, is 3/4. Negative 5/4 and 28/4 would be 23/4. 1 and negative 1 would make 0. 0 and 0 would still make 0. 3/4 and 16/4 would be 19/4. And last but not least, 1/2 plus 6/2 would be 7/2. And none of those fractions simplify, so that's our answer. 4 doesn't go evenly into any of these numbers, and 2 doesn't go evenly into 7. So the last thing we're going to do here with this is show you that you might remember doing sort of basic algebra in a previous year, I'm going to show you that you can still do basic algebra with these matrix things. And so here we go. We're going to show that algebra still works. Don't know what x is, but I'm multiplying it by 2, and I'm subtracting this matrix. Excuse me, positive 1. So x is some matrix, so that when I multiply it by 2 and subtract this matrix, the answer is this matrix. And you might say that's really, really tough, but here's what I want you to think about. What if I asked you to take and just do one little piece of this? What if I just asked you to do 2x minus 3 equals 1? The idea here is this and this element are corresponding. And so, do you remember how to solve this? Well, hopefully you remember that you add 3 to get 4, and then you would divide by 2 or multiply by a half and get x is 2. So real quick, we've added 3 and then divided by 2. And maybe even though we haven't really reviewed that yet this year, I can get you to agree that, yeah, you do kind of remember doing problems like that. So we're going to kind of do it all at once and see if we can handle that. So what we're going to do is, instead of subtracting right here, what we did was we added to move it to the other side. So 2x is going to equal, and this really is like we're solving a bunch of equations at once. So we're going to add this over to the other side. Okay, 3 and 1 would make 4. 7 and negative 5 would make 2. Negative 1 and 4 would make 3. Negative 2 and 0 would make negative 2. 8 and 3 would make 11. 1 and 2 would make 3. We'll go back over quickly why I was able to do that. Since it was a subtraction problem, I would add. And so we kind of looked at a minute ago adding A and B, and was this our answer? Right here, look. Mr. Carpenter's a sneaky, sneaky guy. Look at that. Here's part of, you already agreed to this earlier. Now I'm just kind of using it here. So you add the B over, you should get the same idea. The part of this that's kind of tricky is then now how do you get rid of the 2? You can't divide by 2, as much as some of you might be tempted to do here. Instead of dividing by 2, you need to multiply by a half. Because you can multiply both sides by a half. Excuse me. The 1/2 and the 2 cancel out to just x. And then half of 4 is 2. Half of 2 is 1. Half of 3 is 3 halves, or 1.5. Half of negative 2 is negative 1. Half of 11 is 11 halves. And half of 3 is also 3 halves. We had both 3 halves there. And that'll be it. The reason why I decided to stick this right here is to see early in the year, could you handle sort of learning something about that maybe you didn't really know very much about through this method. And if you don't feel like this worked for you, we need to talk about that and see if maybe there are some things we don't try this method with. Maybe there are some things that we need to just worry about doing in class. In fact, there's something else I could have done with this lesson that I'll only be doing in class. But for right now, that's it. I will see you next time. I will see you in class, and hopefully this worked pretty good for you.